All right, so today's lesson is about the law of cosines. In the last section, we used the law of sines to help solve triangles when we knew two angles and a side, if we had an ASA or an AAS case, and then also that tricky SSA case that sometimes threw us some issues. But we use the law of cosines when we have side angle side and side 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 cases. Okay, so when we have two sides and if we have a side angle side or three sides, here's where we're going to have to use the law of cosines. Now these look pretty confusing, but they're really closely related to each other. Don't think about it as three formulas. So the first one, a squared. Notice that here's side length A, that we have a squared, and then notice that we have this angle A that's here, okay? So notice that we have a squared equals b squared plus c squared, but now we're going to subtract 2bc times the cosine of a. So notice that the side that's by itself over here matches with the angle, and these two sides are multiplied by 2 multiplied by the cosine part, okay? So then b squared would equal a squared plus c squared minus 2 times those two sides ac times the cosine of b. So what would this last one look like then? It would be c squared equals a squared plus b squared minus 2ab times the cosine of c. Okay, so then after we found one of the things with the law of cosines, then we can use the law of sines, which hopefully you've become more familiar with. There are rules, though, that you have to keep in mind if you decide to use the law of sines. Using the law of cosines the whole way is safer because the order doesn't matter, but sometimes the law of cosines can be cumbersome for people, okay? So here's what we'll do is that we're going to attack these by starting with the law of cosines, and you have to use the law of cosines because the law of sines won't work for those cases. So if law of sines doesn't work, go to law of cosines, and then we'll use the law of sines. So if we have side angle side and we have an acute angle that's given, after we find the last side, we'll use the smaller side to find a small angle. And again, basically we're saving the largest angle for last in that case. That's the clue with SAS, is that you want to save the largest angle for last. Then if it's side, 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 you find the largest angle first so that you're weeding it out to get the obtuse angle. Because the cool thing about cosines is that, remember, the law of cosines will get, like inverse cosine will give you a quadrant 2 angle. So we'll find the largest angle first if it's side, side, side. So I'll show you kind of that thought process as we go forward. So this wants us to solve triangle ABC with this information. Notice we have two sides and we have an angle. Notice we couldn't use the law of sines because we have an angle C and we don't have a side C. So what we'll have to do is set it up this way. We'll say, since we know angle C, we'll say that side C squared equals a squared plus b squared minus 2ab times the cosine of angle C. So it looks like this, that c squared equals 22 plus 15 squared plus 2 times 22 times 15 times the cosine of 108. Now the nice thing about this is that we can punch this whole thing into the calculator because it's all on the same side. And I got about 912.95 when I put that whole thing in the calculator. So again, you can put the whole thing in, 22 squared plus 15 squared minus 2 times 22 times 15 times the cosine of 108. And again, there's that 912.95. Now that's not the length of side C. Notice we have to take the square root. So if we take the square root of that, we get about 30.2. So that's going to be the length of side C. We get that side C is about 30.2. now that we've used the law of cosines, now we have a side and an angle opposite that side, so we can use the law of sines. But let's think about it to make sure that we don't end up like screwing over an obtuse angle. So because we are using side angle side, we're going to use the small side in the law of sines. So which is the smaller of these two sides? 15, okay? So we're going to use B equals 15 in there. So we have that 30.2 over the sine of 108 because that is side C and angle C. And now we can set that equal to 15 over the sine of B. So we can do our cross multiplication and isolation, and we'd end up with 15 times the sine of 108 over 30.2, oops, not degrees, 30.2 is the sine of B. And now we can take the inverse of 15 sine 108 over 30.2, and that gives me about 28.2. So that's the measure of angle B. The measure of angle B is about 28.2 degrees. So what's left? We have side C and angle C, side B and angle B, side A. We're missing angle A. That's going to be easy. That's the best part. We're going to take 180 degrees, subtract off the 108, subtract off the 28.2, and using the triangle sum theorem, get that the measure of angle A is about 43.8 degrees. Okay? So, take a minute and try the first you've tried. Okay, so here's what I got for the you try. The first thing I did is I set up the law of cosines to find side B. I said b squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 48. That's about 56.94. Took the square root, get 7.5. But if you're going to use the law of sines, then make sure that we're definitely not trying to find an obtuse angle, so we use a small side so that in the law of sines there's no potential obtuse angles in there. So we'll use 8. And we find that the measure of angle A is 52.4 degrees, and then the measure of angle C is 79.6 degrees, okay? So let's look at this case. Solve triangle ABC with A is 19, B is 26, and C is 31. Well, notice here we have all three sides. So because this is side, 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 let's use the law of cosines to pull out the potentially obtuse angle. Which angle would potentially be obtuse? It will be the one across from the largest side, okay? So when it's side, 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 we're going to find the largest angle. Here, in this problem, it's going to be angle C. So that means because we want the largest angle, we would have 31 squared equals 19 squared plus 26 squared minus 2 times 19 times 26 times the cosine of C. Now, let me tell you what not to do. Kids think that they can do this, and it's a really bad plan. Like, I can't give you any credit after this if that's the case. What some kids try to do is they try to put this whole thing in the calculator. That's not a good thing to do. You have to think about the order of operations. This is all not the coefficient of cosine C. The only coefficient of cosine C is negative 2 times 19 times 26. So what I want you to do is I want you to get rid of these guys. I want you to take 31 squared and then subtract off the other squared parts. Then that gives you negative 2 times 19 times 26 times the cosine of C. Now you can put stuff in the calculator, and you're going to get a number here, and you're going to get a number here. Okay, this is my friendly suggestion because I've been doing this quite a while. All right, so I take 31 squared minus 19 squared minus 26 squared, and I got negative 76. Now I'm going to take negative 2 times 19 times 26. I get negative 988, okay? So when you do that, notice now we have values that are a little more tangible to us. So what we can do then is divide by negative 988. I see that the two negatives are going to divide out, so I'm just going to leave that as 76 over 988 equals cosine C. And now to find the angle C, of course, I will use the inverse cosine. So the inverse cosine of 76 over 988 gives me about 85.6 degrees. So that's going to be my measure of angle C. My measure of angle C is going to be about 85.6 degrees. Notice that it's a pretty large angle, but it's not obtuse, okay? But that was potentially an obtuse angle that we could have gotten using that law of cosines. So let's take then 31 over the sine of 85.6 degrees, and then we can pick whatever one you want. You want to do A first? Sure. So we're going to take O equals 19 over the sine of angle A. And so to find the sine of A, that's going to be 19 times the sine of 85.6 over 31. Finding the inverse sine of 19 times the sine of 85.6 over 31. That's going to give me about 37.7. So the measure of angle A is about 37.7 degrees. And the only thing missing is that third angle, the measure of angle B. I'll take 180 minus angle C minus angle A, and that gives me about 56.7 degrees for angle B. So the two things about when you have an SSS case, first, make sure that you always start finding the largest angle. And then secondly, be very careful when you're isolating the cosine C before you take the inverse. Again, these are my friendly suggestions to move all the squareds to one side, evaluate, then divide and do the inverse. So now take a second and do this you try, okay? Okay, so here's what I did. I looked and I saw that my largest side was side B. So that's potentially my largest angle. So I set up 16 squared equals 14 squared plus 9 squared minus 2 times 14 times 9 times the cosine of angle B. Moved all my squareds to the left, and I ended up getting negative 21. Multiplied on the right to get negative 252 cosine B. Then divided, took the inverse cosine of 21 over 252 to get 85.2 degrees. At that point, then it doesn't matter what other side you use for the law of sines, because we've gleaned out the potentially obtuse angle, and these are the other measurements that I got. I got that measure of angle A is about 60.7 degrees, and the measure of angle C is about 34.1 degrees. That's the gist, okay? Okay, on the back, this says the length of the sides of a triangular plot of land are 150 feet, 150 feet, and 175 feet. Find the largest angle of the triangle. Well, like we said before, the largest angle is going to be the one across from the longest side. So that means that we would use 175 squared on the left, and that means that 120 squared and 150 squared would be on the right of the equation we're looking at. And then since it's the third angle, I'll be super creative and call it the cosine of C. All right, so then anyway, so what we would do at this point is then we would continue to do what we did before. We would basically take the 175 squared, we'd subtract off the 120 squared and the 150 squared. And so if I move these over to the other side, I get negative 6275. And if I multiply negative 2 times 120 times 150, I get negative 36,000 times the cosine of C. So essentially, I'm finding the inverse cosine of 6275 over 36,000, and it finds, if we were to do that, I'll just show you real quick. we get 79.96. If we're rounding that to the nearest tenth, of course, that's just going to be 80.0 degrees. So you might have a story problem, and all they're asking you to do maybe is find one of those pieces. So now go ahead and give this next U try a whirl. All right, so because it's asking us to find the angle B, that is across from the 335 centimeters, so I put that on the left, everything else on the right. And notice this time when I took the inverse cosine, it was of a negative value, and that's why we got the obtuse angle, because the reference angle the inverse cosine, if it's an obtuse angle, has to end up in quadrant 2. And so we know that that's going to be the case if that's a negative here. Okay? So the last thing we're going to look at is Heron's area formula. The area of a triangle with sides of length A, B, and C and semi-perimeter S is as follows. The area is the square root of the product of S times S minus A times S minus B times S minus C, where S is the semi-perimeter. Semi is half, right? A semicircle is half a circle. Semi-perimeter is half the perimeter. So to find the perimeter, you add the sides up. So semi-perimeter, you add the sides up and divide by 2, or multiply by half, same thing, okay? So this says, find the area of the traffic triangle shown in the figure. I've never seen a traffic triangle. I don't even know what that is. But here's what we would do. The first thing we do is we find the semi-perimeter. So we're going to take that S equals 1/2, and we'll add the 3 sides together, 750, 410, and 620, okay? So we can even do that here. We can take 750 plus 410 plus 620, divide that by 2. We find that the semi-perimeter is 890. That means that the area then will be 890, the S. Now we're going to take 890 minus 750. We're going to take 890 minus 410 and 890 minus 620. That's essentially what we're going to be multiplying together, okay? So you might want to just find what those differences are. So, so this is, if we subtract here, that gives me 140. If I subtract here, that gives me 480. If I subtract here, that gives me 270. But just be careful when you're taking the square root. I would multiply all of the numbers together and then take the square root. So I would take all the stuff under here, 890 times 140 times 480 times 270. And then you get a number in scientific notation. That's okay. Just take the square root of that answer. And I find that my area is about 127,075.4. And then let's see what my units are. Feet, and area means I have 2 dimensions, so I'm going to square the dimensions and end up with square feet. Yes, this formula has to be memorized, okay? So take a second and try to find the area of this triangle ABC. Notice these sides are much cuter, okay? So take a second, do that. Okay, so what I did is I started by finding the semi-perimeter, which was 10. And then instead of writing everything out, because I could do this in my head, so to find the area, I took the square root of 10 times 10 minus 7, which was 3, 10 minus 4, which was 6. Sorry, we had a little technical difficulty there. And then 10 minus 9, which was 1, and that gave me 180. And then I took the square root of 180, and then I get about 13.4, but I'm a good student. Even though it doesn't have units, I'm going to mark this as square units because I am a pleaser, and you should be too. All right, so hopefully that makes sense for law of cosines. Again, if you still have trouble, Google law of cosines. Okay, you guys have a great day.